All right, we have one more thing which we need to talk about here in this section of dealing with the rules of logic. And this deals with something called the biconditional, and we would like to understand what the biconditional is and what it means and how to evaluate it. The biconditional goes, it looks like this symbolically, okay? And we write P if and only if Q. Okay, so let's use an example here. So you may go out to play if and only if you eat your broccoli. Okay. So you may go out to play if and only if you eat your broccoli. Well, let's see. What is the P value here? You may go out to play, right there's our P. You eat your broccoli, that's our Q, all right? So we'll mind our P's and Q's, and we'll see if we can figure out what that means, okay? So here is P, here is Q, here's P, if and only if Q, true, true, false, false, true, false, true, false, okay? So, you may go out to eat if and only if you eat your broccoli. You go out to play, you've eaten your broccoli, they're both true, absolutely you can go out to play. Here, you can see that this is a kind of condition for this to be met, right? And so, you may go out to play if and only if you didn't eat your broccoli. I'm sorry, there is no way I'm going to let you go out to play if you didn't eat your broccoli, because it says you may go out to play if and only if you did eat your broccoli. So this is false. Well, here you may go out to play if and only if you eat your broccoli. If you ate your broccoli, is there a way I can legitimately deny you from going out to play? And the answer is no. Okay. So this part is false. I have essentially guaranteed that going out to play and eating your broccoli mean exactly the same thing. You know, you get to do one if you have done the other. Okay. You may not do one if you have not done the other. So here, you may not go out to play. You did not eat your broccoli. Well, this is a just punishment right here, okay? So this is a true statement right there. Here is the essential meaning. P has the same truth value as Q. You can think of it as sort of an equal sign. Does P have the same truth value as true? Yes. Does P have the same truth value as Q here? No. Does P have the same truth value as Q here? No. And does P have the same truth value as Q here? And the answer is no. All right. So you can see what we have there. Well, this biconditional actually sort of looks like two arrows. It looks like an if P then Q, and it looks like, essentially, look at this, an if Q then P. Now, you know, we don't write that like that, do we? Okay, but it's still the same idea. So here we'll do if Q then P. But you could see we possibly could draw the letter backwards. It looks like it in there. So if P then Q, what do we know about if P then Q? Well, we know that a conditional is only false if the condition is met and the promise is not kept. So this, under this thing here is this. Here this is the condition, here is the promise, okay? So where is the condition met and the promise not kept? The condition is met and kept my promise Here the condition is met, the promise is not kept, so that part's false there. And these are true. Okay. Now notice that if I put these together with an and statement, okay, if I put these together with an and statement, all right, notice true and true is true, false and true is false, true and false is false, true and true is true, and here's this, it's the same thing as that. This is saying essentially if P then Q and if Q then P. If you want to go out to play, if you may go out to play, then you will eat your broccoli, and if you eat your broccoli, then you may go out to play. And it puts it both together, and it's a very, very hard and fast way of making sure that what you want to get done gets done before the promise is kept. Okay. Does that make sense? I hope that it does. You have yourself a good day.